All right, let me go ahead and show you what I'm talking about when I'm referring to the paleo-Atlantic shorelines and how we might be able to relate them to the dating of the Carolina Bays. Now, this image right here happens to be Sapelo Island, Georgia. It is a current barrier island, and it has been in formation for around 6,000 years. That's as long as the sea levels have risen, and they've been pretty stable over that 6,000 year period. Now, during the peak of our last glacial maximum, during the peak of the Ice Age, this shoreline wasn't here. This shoreline would have been 100 miles farther away and around 300 or 400 feet deeper or lower in elevation than it is today. And that's really important. I mean, these pachyderms up here that are hanging out on the beach, that would have been happening way farther away than it is today. And in fact, there is a Clovis occupation site just off the shore of this beach. It's called Gray's Reef. There is a known chert deposit there, and there's evidence of Clovis people excavating and using chert on that site for stone points and things like that. And that's like 17 to 19 miles offshore and like 60 feet down under the ocean. So, you know, and that was during the Younger Dryas, that was during the Younger Dryas period. And so sea levels have risen all the way up to this current spot and have been pretty stable there for the past 6,000 years. So we know that sea levels come and go with the coming and going of ice ages. When there's a mile or two of ice on top of the entire country of Canada, sea levels are way out there. And when all that ice melts, sea levels come close to where we are and presently are, where it is today. And now, thanks to the Greenland and Antarctica ice cores, we can match those ice ages to time frames, or what they call MIS stages, marine oxygen isotope stages. And that gives us a really good detail, fairly as detailed as I think we're going to get right now, timeline of when these ice ages came and went, which also means it gives us a timeline of when these shorelines came and went in the past. And so now we can match up shorelines of the past with marine oxygen isotope stages of the past. And I think that's huge. I think that's a really big step in the right direction. Now, this cross-section right here, I got from a field trip guide that Valdosta State University used to use. They would take their students to Sapelo Island, and they would backtrack to where the paleo-Atlantic shorelines used to be and make comparisons. And so obviously, if you go to the beach today, that's where we are present. And if you look at that graph in the middle there, on the far left side of it, I have it marked as today because, again, that's where we are right now, and we know where that shoreline is. But what's crazy is that 125,000 years ago was the last time we were in an interglacial period. It's called the Eemian, and sea levels were higher than they are today. And again, that's at no fault to soccer moms driving SUVs or anything like that. Just natural processes brought the sea levels up to about 30 feet or around 9 meters higher than where they are today. And we can find that shoreline. It's one of our sandhills. It's one of our ancient barrier islands or paleo-Atlantic shorelines. Now, again, if you go back and look at that graph, you can see that ice ages came and went. They all match up to these MIS stages. And the last time that sea levels were higher than they were 125,000 years ago was around 400,000 years ago. And sea levels are around 42 feet higher than they are today. And we can find those shorelines as well. And so, again, we can use these paleo-Atlantic shorelines to kind of set a timeline of when the last time sea levels were higher than they are today. Going back around 1 million years, because if we go back around 1 million years, like the whole entire area here was covered in ocean water. So, we basically, we know for sure that anything that we find on the ground, as far as landforms, have to be younger than 1 million years anywhere on the coast, because 1 million years ago, like the whole area was covered in ocean water. Okay, so, with what I have, I did the best I could, and I went ahead and marked where this image from that field trip guide can be found on Google Earth, and that's going to be a really helpful indicator for us when we go to look at this stuff. But that up there is a Google Earth image of the actual field trip guide that we could use to locate these paleo-Atlantic shorelines. And this is that same area using the USGS LiDAR provided on Cintos.org. You know, thank you, Michael Davies. And right away you can see that we have red dots that represent Carolina bays, and we have vast areas that show no Carolina bays. And as I mentioned in the last video, this right here, you know, raised quite a few questions that I'm still working out today. For instance, if this event was a Younger Dryas event, we should find Carolina bays all across the coast, all the way to the shoreline, because the entire coastline would have been free of ocean water over the past 13,000 years. Sea levels have not risen up to this point up until about 6,000 years ago. And so this whole area should be covered with Carolina bays, and they're not there. They're totally gone. And just to give you another example, and my time is running out, but just to give you another example, you know, this is an image that I think shows it really, really well. This is just off the coast of Myrtle Beach, South Carolina. It's actually North Myrtle Beach. And you could really see some really clear Carolina bays just from the Google Earth images, you know, all over here on this side. But we're actually seeing, what I like about it is that we're actually seeing the process of Carolina bays being erased by the ocean right now in this area. And when I click over to that LiDAR image, you can clearly see that there are areas where we find Carolina bays, and there are areas where there are no Carolina bays. And those areas match up perfectly with the paleo-Atlantic shorelines of the past. Specifically the ones, you know, for sure the one that occurred 125,000 years ago. We don't see any Carolina bays under 30 feet in this area at all. And I do believe that we see some bays in between 30 and 42 feet, but they are heavily eroded, and most of those are found on the leeward side of what would have been a barrier island. I'll get into a little bit more of that here in the next video. I've got to run. But we'll get into it a little bit more next time. Thanks, guys, and we'll catch you next time. Bye.